right, we shall continue on. All right, so we are comfortable looking up numbers to find the area to the left. Okay, what if I flip this around? Okay, I flip it around, and I say, okay, what if I do this and I say, right here, I have 70%, 0.700 to the left. And I ask, where did I draw my number? Or where did I draw this line? Okay, can you guys tell me? So you're going to have to look this up in your table somehow.
It's gonna be like here, like this. It's gonna be here, I think.
0.7?
I don't know, just guessing.
Yeah, I didn't even look up the answer.
There's so many numbers. Or it's here.
It's a rule. It's continuous. 0.7.
Okay, so about where did I draw my line then? Yeah, well, do we have an answer?
Minus 3.8.
No.
No, minus 3.18. Sorry.
No.
What?
I'm going to say 0.52.
What?
0.52.
Yeah, what did you get? Oh, never mind. I looked at 0.0007.
Okay, so I've got 70% to the left of this line, okay? So we know it, like from the picture, we know the number has to be positive, right? Because if I draw a line at 0, I only have 50%. If I have more than 50%, it's got to be to the right of 0.
How did you find
Okay.
Yeah.
number to that, right?
Yeah, so we're looking for the number closest to 70% or closest to 0.700. Okay? And the number that I have closest, it comes between either 0.52 and 0.53, and 0.52 is closer. Is that okay?
Yeah.
It's either 0.52 or 0.53, and 0.52 is closer.
So we should find 7,000 close to
Not 7,000, but 0.7.
There
There's
is
a number
0.7.
closest to 0.7, or 0.7000 if you wanted to stick on zeros.
Okay.
Okay,
On the
is that okay?
It's around
So
0.
let's try a few examples here. Okay. All right. So the area to the left is equal, and I'm going to switch it up between area to the left and area to the right. Okay. Area to the left is equal to 0.17. Okay. Where's the line? Okay. Area to the right equals 0.025. Where's the line? And the area to the left is equal to 0.04. Line. Okay, so I've got area to the left is equal to this amount or to that amount. Here, actually, let me change this last one, not to 0.04, but to 0.86. Okay, just do your best.
big numbers, so maybe.
Alright, are we doing okay or are we totally lost?
Okay.
Totally lost?
Yeah.
Totally lost? Alright. So for these things, it helps to draw a picture. It helps to draw a picture. Okay? So we're asking, where did I draw the line? Okay, so the first one says the area to the left of this line is 0.17. So this is my curve. Where should I draw my line? So should I draw over here or over here? Where should I draw my line? So tell me about where I should stop.
Stop. Left of 0.
There.
Right here.
Yeah.
Yeah, okay, so I'm gonna draw a line over here, right? The 0 is right here, and I'm drawing a line here. And how much is shaded in? 0.17,
Yeah.
okay? So what is the number that's gonna give me 0.17 as the area?
-0.9.
Negative 0.9 what?
5.
Yeah, negative either negative 0.95, yeah, negative 0.95 is the closest one, okay? So the answer there is negative 0.95. You don't get it? Okay, so when you look at the table, I'm looking for a number very close to 0.717, okay? What number is close to 0.17, okay? And if I look, all of these numbers are in order. You're like, this is too many numbers to search for. It's a lot of numbers, okay? But I've got two numbers that are very close to 0.17. I got 0.1711 and 0.1685.
So,
Alright,
these
you guys see those
questions
two numbers?
Are backwards. That's
Huh?
why. These questions are doing those.
Yeah, we're doing the backwards
that's
of what
why.
we're
Okay.
going, okay? So I find 0.1711, that's the closest number I have, and that is in the row negative 0.9 or negative 0.9, you guys like that, and then in the column 0.05. Okay? And so that means the number is negative 0.95. Yes, question?
It's like about right. So let's say like I were to like do negative 2.6 to like the second 0.02, like would it be like how would you write that out again? Like you get what I'm saying? Like
Okay.
how would you know to write negative 9.5 and like not?
Okay, because it's, well, what would you want to write?
I wouldn't be sure like it would be.
Okay, so this, alright, so can everyone see in their table 0.1711?
Yes.
Okay, and it's in the row negative 0.9,
Yeah.
and it's in the column 0.05.
Yeah.
Okay, so you put those two together and you get negative 0.95. Okay, you just take 0.9, 0.05, okay, and you get 0.95. Alright, do not say it's negative 0.905. This is not right. Okay, it's negative 0.95.
It's a little confusing because there's an extra zero in the column.
This is the tens place and this is the hundreds
Yeah.
place. That's all it's doing. Okay. You guys can figure this out, all right? It's, everything, the first few times you do it, it's awkward, then you get better at it. Like riding a bicycle. All right. Is that okay?
Yeah.
Let's do this third one. Okay, area to the left is equal to 0.86. area to the left is equal to 0.86. I know some of you guys, you got this, and this feels boring to you. Others of you, I know, and others are having some trouble, so I'm trying to just get everybody through it. Okay, so it's saying the area to the left is 0.86. Okay, so I'm looking over here for the number that's closest to 0.86. What's the number I have that's closest to 0.86?
It's 621.
1.08.
0.8599, right?
Oh, yeah.
0.8599 is super, super close to 0.86. And that is in the row 1.0 and the column
0.08.
0.08. So the number is
1.8.
1.08. 1.08. Not 1.8, not 1.008, 1.08. Okay? You got it. You can't get your placeholders messed up, okay? You put those two together, 1.08. Yes.
So basically, 0.86, you just look through all this here.
You look through all of this,
And then
you're
you
trying to
go-
find the number closest to 0.86, which is 0.8599. And you take that row and you take that column, and you put those two together and you get 1.08.
But the number cannot be different.
Okay, so this is at 1.08. Yes.
Yes.
Yes. Okay, so the last one, or the middle one, I said the area to the right is 0.025. Okay, so what do we have to do first?
Find out the left one.
We'll find the area to the left. So what's the area to the left? If the area to the right equals 0.025, then the area to the left is equal to 1 minus 0.025, and I get 0.975. Alright, and what's the number that's closest to 0.975? Yeah.
2.
Okay, no, we actually find 0.9750 in there exactly. And it's in the row 1.9 and the column 0.06. So this is at 1.96. All right, we got to move on. Okay. If you're having trouble, just go back, watch this, rewatch this part of the video, and we can do this. All right. Okay. So this table that we use, the standard normal table, is also known as the Z table, because if you look at the top left corner of the table, you see a little Z in there. Okay, so this is our Z table. And we have something called the Z-score. A Z-score, this is an important definition, is the number of standard deviations we are from the mean. A Z-score is the number of standard deviations we are from the mean. If the Z is positive, we're above the mean. If the Z is negative, we're below the mean. Z-score is the number of standard deviations we are from the mean. Write that down. If it's negative, it's below the mean, right? Positive means above the mean. Negative just listen and let's see if we can understand this, all right? Let's say I say the average weight of, I don't know, there's some boxes here, okay? And the mean weight of a box is 110 pounds. Okay, 110. And let's say the standard deviation is 5 pounds. So the mean is 110, the standard deviation is 5. Okay. If something weighs 115 pounds, what is its z-score?
Fun.
Plus 1.
Plus 1. Plus 1. Okay? 115 pounds is 5 pounds above the mean of 110, and each standard deviation is 5 pounds, so it has a z-score of plus 1. Are we able to process this audibly?
Yes.
Okay? Alright. If a box has a z-score of -2, don't shout out the answer. If the box has a z-score of -2, how much does that box weigh? Think of it in your head. Okay, how much does that box weigh?
100 pounds.
100 pounds. Okay, each standard deviation is 5 pounds. It has a z-score of -2. It's 2 standard deviations below the mean. It weighs 100 pounds. All right. Okay. If a box is, let's say, 102 pounds. 102 pounds. This one's a little bit trickier. If a box is 102 pounds, what is its z-score? Okay, so let's say the mean, again, is equal to 110, and the standard deviation is equal to 5. If a box is 102 pounds, what is its z-score?
Minus
1.8.
Minus 1.6. Okay, so a box, so let me just write a few things down. Okay, so a box weighs 115, then the z-score is equal to plus 1. Okay, a box with z-score equal to -2 weighs 100. Okay, and we did this. That's fine. Okay, so then we said a box weighs 102. Then the z-score equals -1.6. Now, how do we get this one? All right. Now I'm going to introduce the z-score formula. Okay, but we did these two first, a few of these first, just because I think you guys can think about this clearly and know what's going on, okay? Because once I do the formula, everyone's going to just be like, let's use the formula, and then they forget what's happening, okay? All right? I just want to make sure that we still got this. Okay, what if a box weighs 120 pounds? The z-score is then plus 2, okay? All right, and if a box weighs 95 pounds,
Minus
3.
the z-score is
Minus 3.
-3. Okay. All right. So z-score, the z-score formula is equal to the number that we're interested in, the x minus the mean divided by the standard deviation. Okay. Sometimes we use symbols. So that will be written as x minus mu divided by sigma. Okay, we've already done z-scores, right? Or we had before x minus x bar divided by s. Okay. If it's in a normal model, we have mu and sigma and all of this. Okay, so we've dealt with z-scores already. We saw them on our first quiz. Our z-score is the number of standard deviations we have from the mean. Okay. We have a question.
Do we have to remember the mu and
No. Okay. As long as you know a z-score is
Yeah.
x minus the mean over the standard deviation, you're in good shape.
Okay, cool.
Okay.
Thank you.
It'll even be written on your test, one of them. problems, okay? Alright, the thing is if we've got a normal distribution, we can turn things into the z-score and look that up in our z-table. Alright. I forgot how much a tiger weighs. That was on our first quiz, right?
Yeah.
But I said, okay, so let's make up some magical tigers, okay? A magic tiger. Alright, follows the normal model. The weight of a magic tiger. Alright, the mean is equal to 950 pounds with a standard deviation of 80 pounds. Alright, and I want to know what percentage of tigers, of magic tigers weigh less and then say, let's say 905 pounds. Okay, so there's 2 steps. Okay, first you're going to find the z-score and then look up the z-score. Yes. Okay, in the interest of time, I'm just going to solve this for you guys, alright? So pay attention. Alright, so the first step is we're going to find the z-score. So what is my z-score? Z is equal, I'm going to do 905 minus 950 divided by 80, and I get negative 0.5625. Yeah, negative 0.5625. It's very important that we have negative. We're going to look this up in the z-table, okay? When I look this up in the z-table only goes to 2 decimals, so I have to round to 2 decimals. And I get z equals negative 0.56. And I look up negative 0.56 in the table, and what do I have? 0.2877. Okay? Area to the left equals 0.2877.
But do you look in these numbers, or do you look in column and row? That's what I was
Yeah, so the column and the row are the z-scores, okay? So I'm going to look up column and row. I'm going to look up the row that's negative 0.5 and the column 0.06. So in this case, alright, if you're not sure which way to go, ask, am I given a measurement or am I given a probability or area? And in this case, we were given a measurement, a weight. So if we're given a measurement, we look up column and row. And if you're given a probability or area, you look in the other part, the area of the table. Okay? If you're given an area, look in the area table. Okay, so the area to the left is 0.2877. Alright, so my question was, what percentage of magic tigers weigh less than 905 pounds? And you would say 28.77%. How did I get that? Yeah, times 100%, right?
Would you do
Yeah.
would you do the same if your example weight was higher than the mean?
Exactly. You would do the exact same thing, except you just look on the positive side of the table.
Yeah. Because when you found, you know, what's the shaded side on the right, then you did it differently than for the left, you know?
You know, if I said, what's the percentage of tigers weigh more than 905 pounds,
Right.
then we would have to do something different.
Okay.
All right, so that's actually a good point. Okay, I'm going to change the question just slightly, and you don't have to do a whole lot of math here. And I just say, what percent of tigers weigh more than 905 pounds? Okay, and our answer to that is 1 minus 0.2877, alright? And I get 0.7123, or 71.23%.
So always if you're thinking about what's to the right of the mean, you
Yeah.
should start with one minus, right?
Well, no, go through the problem, and then at the end do 1 minus.
Okay.
At the end do 1 minus, okay? The 1 minus comes at the end.
Yeah. But it's a rule that everything is okay.
Because the table always gives you area to the left. So if you want the area to the right, you take what you find in the table and you do 1 minus that.
Okay.
Okay, we gotta work quickly. We gotta work quickly. Okay, so still we'll say tigers, the mean is 950 and the standard deviation is 80. Alright, I'm going to say 85% of tigers weigh less than blank. Okay? Way less than blank, alright? Or another way of phrasing this, okay, is what is the 85th percentile, percentile of tiger weight? Okay, both of these questions are asking the same thing, they're just phrased differently. 85% of tigers weigh less than some number, or what is the 85th percentile of tiger weights? Okay, which is basically saying, where's the location where 85% of tigers weigh less than this number? So what should the very first thing we do be? We got to find the z-score that gives us 85%. Okay? So I'm going into my table and I'm looking for 8.8500. Okay? The closest thing. Because I'm given a percentage or I'm given an area. The area is 0.85. So what is the number that's going to give me 0.85? Okay? So here my z-score is equal to what? 1.04. Can we see that?
Yeah. So it can be over. The number can be over.
Yeah, we want the number that's closest.
difference.
The closest to it, okay? So I get z is equal to 1.04. Alright? Is that the weight of tigers? No. How do I turn this back into the weight of tigers? Okay? Alright? So each standard deviation is 80 pounds, right? So if I use this, z is equal to x minus the mean over the standard deviation, I have 1.04, which is equal to x minus the mean of 950, plus divided by the standard deviation of 80. And what happens here?
Solve.
I get 83.2 is equal to x minus 950, and I get x is equal to 1,033.2. Okay. Is that okay? Alright, you have to be comfortable with both types of problems. You're going to see both types of problems on your midterm next week.
So if you give us percentage, we just go
In this case, you will go to the table first, find the z-score, and turn the z-score into a measurement. Okay, and one more type of problem that you also have to be comfortable with.
So that's the number we solved.
Okay. I'm going to ask, what percent of tigers are between, let's say, between 900 and 990 pounds. No, we'll do 980 pounds. Okay. What percentage of tigers are between 900 and 980? Okay. For this, let's draw a picture. Okay. We said the mean weight of tigers was 950. And the standard deviation is equal to 80. So if the mean is 950, where should 950 go?
In the middle.
In the middle, right? 950. Okay. There's two numbers that I'm looking for, 900 and 980. 900 is bigger or smaller than 950?
Smaller.
Smaller, so it's going to the left of 950, okay? 980 is bigger or smaller? It's bigger, so it goes to the right of 950. Okay? Make sure you put numbers on the right location. Okay? Because one of your short answer questions there, and I'm giving you major hints about your midterm. You're going to have a problem just like this, okay? And it's going to say, find the area, or well, you know, what's the probability that it's between this and this, okay? And I tell you to draw a picture. All right? And a big mistake, or like one that always blows my mind, is that when students label it, they just get three numbers and they go, oh, I'm going to just throw the three numbers on here, okay? But if I say what's the probability that's between 900 and 920, both 900 and 920 better be to the left of 950, okay? If you put 920 on this side, that's like wrong, okay? No, not like wrong, it is wrong. Okay, 920, there's no number system where 920 is bigger than 950. So don't do that.
Simple mistake.
Yeah, it's not a simple mistake. It's a mistake that people do because they aren't thinking. They're just writing numbers and they think, you know? All right. It's like going to England and driving in a car and you drive on the right side, wrong side of the street, okay? You just weren't thinking, okay? I forgot that was in the comments. Okay. 900, 90, 950, 980. Okay, so we want to know what's the area in between, okay? So how do we do this, all right? Well, what we're going to do is we're going to find the area to the left of 900, okay? We're going to find the area to the left of 980. Okay, so we're just going to go straight forward, and it's basically like what percentage is smaller than 980? and then what percentage is smaller than 900? And then to get what's in between, I just take the difference. So let's say 70% is less than 980, and 30% is less than 900. Well, how much is in between them? 40%. Does that make sense?
Yeah.
So you do area to the left of 980. So that's this piece. Okay, minus area to the left of 900, which is this piece. Okay? Then you're left with what you're looking for.
A box plot?
No, not a box plot. You're just getting the area in between.
It's the same kind of thing where you're taking the percentages from
I get maybe, kinda. I hesitate to say yes or
never
no.
mind.
Okay. All right. Okay. So for the interest of time, I'm just going to do this very quickly. All right. So let's find the area to the left of 980. So the first thing we do is we go z is equal to 980 minus 950 divided by standard deviation of 80. Okay, and I get 30 over 80, and I get 0.375. Okay, round z score to 2 decimals. So we get 0.38. Look up in the table, and the area to the left is equal to 0.6480. Okay, so this part is 0.6480. Then we do the same thing on the other side. Area to the left of 900. Okay, my z is going to be 900 minus 950 over 80. Get negative 50 over 80, which gives me negative 0.625. Okay, round to 2 decimals, and we get z is equal to negative 0.63. Look up in the table, and the area to the left is equal to 0.2643. Okay, so this part is 0.26. Okay, so now I take the difference between the area to the left of 980 and the area to the left of 900. And I get 0.3837. Okay, I'll let you guys copy that down. Do you have a blank sheet of paper?
That's the shade.
Yeah. It's the area. This one better. Okay. All right, I'm going to pass this paper around. This is going to serve as our attendance audit. Okay. Just number it, and print your name nice and clearly. Okay. Do not sign in your friends. I'm going to count how many students are here, and if the numbers don't match up, what I get back on here, then you guys will not get credit for the attendance audit. So do not sign in your friends. Just write your own name. Okay, and pass that around. Okay.
to the left is equal to 0.2643. Oh, no, the area is never going to be net minus, okay? So the z-score is negative, but the area is never negative. All right, is this okay? Is this question okay? I know I kind of went through it quickly, all right? Okay, so star this in your notes. You will definitely see a question like this on the midterm exam next week. Make sure you understand it. Okay? Yes, question? Can I raise the board?
Yeah, like raise it because I can't see the bottom.
Or if you switch
And-
like switch them.
Switch them. You know, unfortunately, because of gravity, it's like the top board always sags down a little bit or something. I don't. Oh no, actually it works. That works. Okay, great. Yes.
And you always do the same, no matter if the two numbers are lower than the mean or higher.
Right.
It's
you
always the same.
you're gonna always take the difference
Yeah.
between the two.
Yeah.
Okay.
So that doesn't
Always
matter.
do the larger area minus the smaller area, and you're left with the area in between.
Yeah. Thank you.
Okay.
It's 38% of time. 38%
Notice the areas that you look up should never be negative. They're always positive. Your z-score might be positive or negative depending on whether it's above or below the mean. Okay.
Will it always be a larger number? Like the number will always be larger for the 980 versus like 900?
Yeah, there's always going to be two numbers, and when you look at the area to the left, one of the numbers will always be bigger than the other number. Okay, when you're looking at the area to the
Yeah.
left, one will always be bigger than the other. So you just do the big number minus the little number. You're going to be left with the area in between. Yes.
Okay, so let's say, like, a question like this, would you ever do, like, to the right of? Or is it always, like, to the left
You know,
of?
I'm always asking what percent are between two numbers. Okay, so just use the area to the left. You never have to worry about the area to the right. Okay. When you're just given one weight, I could ask what percentage of tigers weigh more than 980. Okay, but I won't ask you like between, switch it around or something like that.
So the answer is 38.37%.
Yeah, 38.37% of tigers weigh between 900 and 980 pounds.
Thank you.
Okay. Last week, I don't know if you guys remember this. We talked about probabilities for sequences of independent events. Okay? I hope you guys remember. One example, okay? So an example from last week. I said we flip a regular coin three times. And then I said, what's the probability that we see two heads and one tail? You guys remember that? Okay. And then I said the order doesn't matter, right? And so the way we did this was we said, okay, one way we can get it is heads, heads, tails. Another way is heads, tails, heads, and tails, heads, heads. Do you guys remember this? And then I said the probability of this is going to be 0.5 times 0.5 times 0.5, which is equal to 0.125. And that goes the same for this one. And it goes the same for this one. So the total probability was, I did 0.125 times 3. And I got 0.375.
that okay? Okay, so who has not signed this? Okay, so pass this around and then go to that gentleman right there.
No, last week you added them up.
Yes. Oh, okay. Well, I mean that's the same, right? That's the definition of multiplication, right? 0.125 plus 0.125 plus 0.125. This is the definition of multiplication, right? Okay.
I guess.
Yes. Not I guess. It is. It is.
Yes.
Okay.
Okay.
3 times something means add that thing 3 times.
Oh yeah, that's right.
Okay.
Whoops.
So we said the probability that this happens. Oh no. Okay. The probability that this happens is equal to 0.375. Is that okay?
Mm-hmm.
All right. This is something known as a binomial problem. Okay. A binomial problem is you do the same thing several times. In our case, we're flipping a coin and we're doing it 3 times. Okay? You do the same thing several times. Or multiple times, I should say. Because several implies like 6 or more. And we want to know what's the probability that we see a certain number of successes, okay? But the order does not matter, okay? Order does not matter. Okay, and we want a certain number of quote-unquote successes. All right? Air quotes for successes because it's an arbitrary label. It may not necessarily mean success. So in our case, we want 2 heads out of 3 coin flips. So we flip a coin. We do that several times. We do it 3 times. And we want to know what's the probability of getting 2 heads. And the order doesn't matter. Okay. So all binomial problems have 3 parts, an n, a p, and an x, okay? So all binomial problems, well, they have these conditions, okay? But they also have an n, a p, and an x, okay? So the hardest part with binomial is knowing that you're dealing with a binomial, and then the second part is that figuring out your n, p, and x. The rest is just looking it up in the table. Once you figure out how to use the table, it's very easy. Alright, so in our case, okay, well, actually, not just in our case. So the n is the number of times you repeat the same thing, okay? So we flipped a coin 3 times. Our n is 3. Number of repetitions. So here in our example, in our case, we flip a coin 3 times. N is then 3. Okay. P is the probability of success for 1 repetition, or 1 try, I should call it. Okay, so that means what's the probability I get a head, it lands heads on 1 coin flip?
0.5.
Yeah, so in our case,
So this is the probability of heads on one flip. So P is equal to 0.5. Okay? And here I'm asking, and X is the number of successes we want. Okay? So we want 2 heads and 1 tail. So what is the X that we want? 2. We want 2 heads, right? So X equals 2. So we have N is 3, P is 0.5, X is 2. Is that okay? Alright, so grab your other table that I passed out. Okay, and there's 2 sides. Okay, so the very leftmost column is your N. So we're going to go to N equals 3. Okay, so when you use this, go in the order N, X, P. Okay, so the leftmost column is 3, or N, is N, so we go to where it says 3. Okay, and then you have the numbers in the next column. It goes 0, 1, 2, 3, right? That's for X. You guys see that? Okay, so right up here we go to N is 3, and then we're going to go to the row within that section for X is 2. Okay, and then you find the P that we're looking for. We have P equals 0.5, so we go across to the middle where it says P is 0.5, and what's the number there? 0.375, right? So we go N is equal, so in your table, it looks like N, X, so we have 3, and it goes 0, 1, 2, 3, so then we go to the row 2, and we find the P, where P is equal to 0.50 across the top, right? Okay, and so our answer is 0.375. Okay, and that matches what we did when we found it the manual way, okay? So you can imagine, what if I change this thing to say, I flip a coin 10 times. Now what's the probability that I see 5 heads, okay? Then it would be a lot harder to try to do it this way, right? There would be so many different ways where you could get 5 heads out of 10 coin flips or something. It'd be too tedious, okay? Here we can list off the 3 and it's not too bad. But if I said, so let's try that out, okay? Is this okay? The N, P, and the X, yes.
Why did you say that all binomial problems have NPX when the order we should look is NXP?
I don't know.
It's not another thing that we need to remember?
No. It's just, so traditionally it's presented NPX, okay?
Oh.
It's just when you use the table,
Okay.
you go NXP, okay?
Okay.
But the traditional method has always been NPX, okay? It's just when they make the table, they go NXP. Okay, can I erase this?
Yeah.
Okay. Too bad, I already am. Alright, so let's try this, okay? We flip a coin 10 times, okay? What is the probability that the coin lands tails 6 times? Okay. Alright, so the label success is arbitrary. It doesn't matter, okay? So when we have this, remember, figure out your N, your P, and your X, and then go to the table. So if you think about it for a moment.
P always 0.5?
Not always, okay? I mean, with the coin flips, it's always
It is,
0.5.
okay.
N is what? 10. P is 0.5, and X is 6. Okay? So when I look that up, my probability is equal to
0.205.
0.205. Great. Okay? Alright, so things can change, right? Things, we're not always going to use P equals 0.5, and it's not always going to be coin flips, okay? There is going to be a binomial problem on your test next week. I'm not going to tell you which one it is, okay? You've got to be able to read a problem and say, aha, this is binomial, okay? A lot of students don't see it, though.
What would be the case of like it wasn't a pen, but then what would you replace?
Yeah, okay,
for?
so let's try something else, okay? I'm gonna erase this. Yeah, we could talk about rolling a die, but I don't know. Okay, so let's say I shoot a basketball.
It's not
7 times. Okay? Let's say the probability I make a basket on any, for one shot, is, let's say, 0.3. Maybe that's generous.
Will you always give us that number?
Yeah, I'll always give you the P.
Okay.
Okay, what is the probability I make 2 shots out of 7? If I shoot the basketball 7 times, what's the probability I make 2 of those shots? So N, P, and X, what is, N is
7.
7, P is
0.3.
0.3, and X is 2, and so my answer is
0.318.
0.318.
Questions gonna be formatted just like this?
Huh? It's not too bad, right? It's easy,
Are
okay?
the questions formatted just like this?
Probably not. Well,
Because to know if it's binomial, that's what I was asking.
yeah, okay. All right, let's let's.
8 or 2? 8, right?
Oh, 318. Yeah, 318. Sorry. Okay. All right, let's try something else.
Did you do it many times?
Okay. All right, we got. All right, this is a terrible picture, but there's 10 equal slices. Okay. One is a winner. Okay. The rest are lose. Okay, and we're gonna spin it. Okay. You play. You spin it. Spin it 9 times. Okay. What is the probability you lose all 9 times? Okay. What is the probability you win at least once? What is the probability you win twice? Try that. Okay, is the attendance paper going around somewhere? There, has everyone signed it? Okay, let me get that.
I don't know what P is.
Okay, great. All right. Can we do this one? No, this one was harder. All right. Okay. So what's the probability that we lose all 9 times? Okay. So in this case, what is n?
9.
N is n 9. Okay. P is what?
9.
1 9.
Okay. 10 equal slices. So we have 0.1. 0.1. Okay. So lose all 9 times means x equals 0, right? If you lose all 9 times, x is equal to 0.
Why is it 0.1?
Huh? Because that's the probability of winning. The probability of winning is 0.1, right? There's 10 equal slices. If you're spinning this wheel, the probability that you get the winning one is 0.1. Is that?
Is everyone a winning one?
No. Only this one's winning.
Because
1 out of 10.
equals
1 out of 10 will win.
Right.
Because probability of losing all 9 times is what's the probability of winning 0 times. No?
That means you don't spin it.
Huh? No. We played it 9 times. But how, if I play it 9 times, is it possible that I win 0 times? Yeah. That happens a lot, right? You go to Vegas and you play the slot machine 100 times, you might win 0 times, okay? I mean, maybe not 100 times because they're trying to like hook you in. Okay. Slot machines are terrible. Okay. So the answer here is 0.387. Do we see that?
But how did you get to 0.1?
Because there's 10 slices. One of them's a winner. The other 9 are losers. So 1 out of 10.
Oh,
So P is equal to 1 out of 10, or 0.1. Yes.
How did you get to 0?
Because if I'm losing all 9 times, how many times did I win? 0. Okay. What's the probability you win at least once?
So your x equals 1, right?
1 minus.
1 minus x equals 0, right? So this is 1 minus lose all. So I do 1 minus 0.387. Okay? So I get 0.613.
This is really hard.
Okay, we'll star this in your notes because you might see questions like this, maybe. Yes, you will, okay. What's the probability you win twice?
So do you times that by 2?
No, okay. N is equal to 9, P is equal to 0.1, X is equal to 2. Okay, I do this, and I get my probability is equal to 0.172.
You don't have to look anything up for that one.
Yeah, this one, I look up 9.
That one. The second one.
This one? Yeah, this one, you gotta figure this one out first to answer this, okay? Maybe I'll ask you this without asking you this. No, okay? Okay, we will stop there.